from Makasis Academy. In today's tutorial, we have to learn actually how we can derive the proverbial almighty formula using elimination method. Okay. Normally we have substitution methods to prove this. We have the completing the square principle to also prove this, which appears in two ways: the fractional way and the non-fractional way. But in this case, I will have to employ elimination method. How do I do so? I will have to create two equations of which I am going to solve simultaneously to derive my formula. Now, our topic for today is the proof of almighty formula using what? Elimination methods. Okay. The proof of almighty formula using the method of elimination. Okay, so I said that the topic for today is what? The proof of almighty formula using the method of elimination. Now let us establish, okay, our general quadratic equation in abstract form. Okay, the general quadratic equation is giving us a squared plus b, a squared plus b, x plus c equal to 0. Okay, so in this case, a is a constant, okay, but a non-constant coefficient of what? S squared. S squared precisely is the quadratic term. B is a constant as well. A non-constant coefficient of what? The linear term, x. X is the linear term with the power 1. C is also what? A non-constant, okay? But a free term because it is attached with no variable. The right-hand side is now what? 0. So let's call this our equation A. Equation A. All right. In this case, this quadratic or the quadratic law is that A is not equal to what? 0. Provided A is not equal to what? 0, then this equation is what? A quadratic equation. Okay? Provided A is not equal to what? 0, then the equation is what? A quadratic equation. If A, suppose we are to be equal to 0, then this becomes a linear equation, no more quadratic, because when we substitute what? A, or well, 0 in place of A from the original equation A, then 0 times S squared is 0. So what we are left with is bx plus c equals to what? 0, making it what? A linear or a first degree equation. So we have to prove this now. How do we, first of all, when we say that we want to solve simultaneously, okay, this original equation, how do we do so? What we have to do is to what? Create two different linear equations, okay, for us to be able to solve what? Simultaneously. Now, let us create the first linear equation. Okay, to create the first linear equation, we multiply our equation A by 4A. All right. So this equation A now is to be multiplied by 4A. The result now becomes my equation 1. Okay, that's a new linear equation. So 4A times ax squared will give me what? 4ax squared. That is 4a squared x squared. Okay. So 4a squared x squared plus 4a times bx will give me 4abx. Okay. Plus 4a times c will give me 4ac. 4a times 0 will give us what? 0. Because anything multiplied by 0 is 0. So let's call this equation 1. This is our new linear equation now. Again, we shall also create another linear equation. That is our second linear equation. Okay? How do we do that? We simply differentiate the left-hand side of what? Our original equation A. After differentiating it, for us to have a binomial expression, we have to raise the binomial to 2. Okay? Or simply squaring the binomial. Okay? And again, expanding that binomial to have a trinomial. Or simply we say, setting the binomial equal to its what? Expansion. Okay? That becomes our what? Second equation. Alright, so now let's do it. For the second linear equation, we differentiate the left-hand side of the original equation A. Left-hand side of what? Our equation A. Okay? So, okay, let's say comma. We square the results. We square the results, or the binomial. We square the results, comma, and set the results, okay, to, and set the squared binomial, where that binomial is the result, okay. Set the squared binomial equal to its expansion, binomial equal to its expansion. Okay, so doing that we have, all right, we want to differentiate the left hand side. Okay, so let me do this, dy dx, okay, or simply let's do it, okay, all right, y dx equal to differentiating what? Ax squared plus bx plus c, the constants, ax squared. Okay, so now we have to differentiate this, and what our result shall be is, when we differentiate, okay, or simply we can multiply each of the terms by what? Dy dx, okay, dy dx times ax squared. Okay, now we are differentiating y with respect to x here. If we differentiate the quadratic term, we shall have 2a. If we differentiate, sorry, we will have 2ax. All right. If we differentiate the linear term, we shall have b, well, plus b. If we differentiate the constant, we have 0. Okay, so actually we have a binomial. The result of this differentiation is now what? A binomial. All right. It also told you that after differentiating, you have to do what? Square the result. And the result here is the binomial. Okay, and also set its set the squared result to equal to its what? Expansion. So now let us square the results. Okay, we square the result right now. All right. Okay, at this point we are squaring the result. Actually, we have differentiated already. Please don't become confused. We have differentiated now. Okay, the y, the x, with respect to what? Ax squared gives me what? 2x. With respect to what? Bs gives me what? Plus b. With respect to what? C gives me what? 0. Okay? So now, we want to square it. Okay? We want to square it. Now, we square the result now. Okay? See the squared result. Alright? So now, we have to do this, the last one, which is set the squared binomial equal to its what? Expansion. So the expansion now becomes what? 4a squared s squared. Okay? So we now have 4a x, that is 4a squared x squared. 4a squared s squared, plus 4ab plus 4abx, okay, plus b squared plus b squared. You should, well, I assume that you must have known how to do a normal binomial expansion. Okay, you can use Pascal triangle to find the binomial coefficients. Well, after which you can put it into its what? Standard form. You can use normal binomial formula or combinatorics, okay, to do the expansion. Right now, I just did my expansion. Okay, so, which is equal to what? Equal to the binomial 2ax plus b. Okay, so raised to the power 2. All right, so I call this my second equation, my second linear equation. Okay, so have you seen actually how I was able to create two different linear equations from our original quadratic equation? It is these two linear equations that I am to solve what? Simultaneously. Using what? Method of what? Elimination. So, let us bring down the first linear equation which we created. Okay, and it is what? 4a squared x squared. 4a squared x squared plus 4abx plus 4ac equal to 0. Okay? Alright, that is our first equation. So the second equation now, okay, let's do something here first. Okay, let's do something here. At this point I want to eliminate. Okay, use the elimination method. Alright, so I now write again 4ax plus 4abx, that is 4a squared s squared plus 4abx, yeah, plus 4ac, okay, equal to 0. The second one becomes 4a x, but the a is squared, the s is also what? Squared. Okay, all right, the s is also squared. Gets little difficulty in typing. Okay. All right. Okay. 4a squared s squared. Okay, let me write this first. Okay, plus 4abx plus b squared. Okay, at this point, so this one is squared. Okay, it's not easy for me to write. Okay, Wait. All right. Yeah, it's okay now. Okay. Then b squared, okay, equal to yep, equal to the binomial. Okay. So equal to the binomial. All right. So which is what 2ax plus b raised to the power 2. Okay. So actually I've written the expressions, okay, to be eliminated, or well, the linear equations, okay, which I actually created. Okay. So to do the elimination, simply I shall subtract the first equation from x-like terms in the second equation. The first two terms are the same terms, okay, the same coefficients and the same powers and the same word variables. The same thing goes to the second word terms, okay, the linear term. They are still what? The same term, like terms, okay, which after the subtraction they will turn to what? 0, okay. So now I subtract, okay, the first term, the first equation from the second equation. That turns to what? 0, okay, plus 0 plus 0. That is, this one is 0. You shift, put the sign plus, then 0, or you can still shift to write 0, okay. Then b squared minus 4ac will give me plus b minus 4ac equal to the binomial raised to the power 2. That is the binomial of the second degree. Okay. 2ax plus b raised to the power 2. All right. So note that the b is squared. Okay. Write it here. The b is squared. Okay. So after our subtraction, what I have now is what? 4a squared s squared minus 4a squared s squared gives me 0. Again, from the linear terms, 4abx minus 4abs gives me 0. Again, from the constants, b squared minus 4ac is b squared minus 4ac. Then from the right hand side, the binomial raised to the power 2 minus 0 is still the binomial. Nothing changes. Okay, so let us now write out the one we've seen. All right, so we are left with what? B squared minus 4ac equal to the binomial of the second degree. Okay, 2ax plus b raised to the power 2. All right, the b is also raised to the power 2. Okay, what else do you do? What else do you do? Okay, what else? Now, another step is also what? Remove these two from the right hand side. Okay, these two at the top right of the binomial from the right hand side. Let us remove it. How do we remove it? We take the square root of what? Both sides. Or simply, we can say raise the power, or raise both sides to the power of what? Half. That is 1/2. Doing so, we can be able to what? Eliminate these two here from the right hand side of the binomial, top right of the binomial. Okay, or simply we can say take the square root of what? Both sides. Okay, and that gives me plus or minus square root of what? B squared minus 4ac. Okay, b squared minus 4ac, the b is squared. Okay, so equal to, when you take the square root of the right hand side, the square root, which is equal to 1 over 2, we cancel the power 2. So I'll be left with 2ax plus b. All right. Again, we take the b from the right hand side to cross the left hand side. That will change to what? Minus b plus or minus root b squared minus 4ac. B squared minus 4ac equal to 2ax. Then finally, what we are solving for is x. Okay, how do we solve for x? We shall divide through, okay, both sides of the equation by the coefficient of x, which is what? 2a. So far as a is not equal to what? 0. So we divide through. Okay, so dividing through by such, we have, okay, this fraction here, minus b plus or minus square root of b squared minus 4ac, okay, b squared minus 4ac, okay, all over 2a equal to what? X. Okay, so at this juncture, note that we actually divided through by 2a. So from the right hand side, 2ax all over 2ax, 2a we cancel out. Okay, so we are left with x. Okay, from the right hand side. From left hand side, okay, nothing cancels out. It just becomes a what? A formula. That is minus b plus or minus root b squared minus 4ac all over what? 2a. So that becomes our what? Almighty formula, or the quadratic formula. At least you have seen how you can actually use the elimination method to derive the known almighty formula. Thank you for watching by Makasi Chinedu. Please, I am responsible to every typographical error or any typographical error found in this video. Subscribe to my YouTube channel, Makasi Academy, where I teach mathematics, economics, econometrics, and the quantitative economics. Hope this helps. Thank you for watching.